Let's solve a rational inequality. When we're solving an inequality, be it rational or polynomial, a key piece of information that we need to know is, are we looking for negative or positive values? And to tell us that, we look on this side of the inequality, are we looking at less than or zero or greater than zero? In this case, we don't have a zero, we have a 2. So the first order of business is going to be to subtract the 2 from both sides. So we have x minus 2 over x plus 2 minus 2, and now we're looking at our less than or equal to 0, which tells us that we are looking for negative values. So negative values are going to satisfy our solution. So to proceed here, normally we would look at the numerator and the denominator to determine our boundary points. But at this particular time, we can't do that because we don't have just a numerator and a denominator. We have a fraction, and we also have a subtraction with the 2. So the first order of business is to deal with this minus 2, or subtracting 2, so that we have one fraction with one denominator and one numerator that we can consider. Let's take the x minus 2 over x plus 2, the fraction that we were given to start with, and now here is our minus 2. Now, in order to incorporate minus 2 into the fraction that we have, we're going to have to use our common denominator, the only denominator we have right now, of x plus 2 over x plus 2, which is, as we know, 1. Whenever the numerator and denominator are the same, we have a 1. So negative 2 times 1 is still negative 2. We're not changing the quantity we're looking at here. What we're doing is, in essence, making the negative 2 more complicated, but that this way we will have it in fraction form with a denominator so we can combine into one fraction. So again, our x minus 2 over x plus 2. And now I'm going to extend the information for the fraction. And what we're going to do is incorporate the information from our minus 2. So this negative 2 is going to be distributed to both pieces of information in the parentheses. And we're going to have negative 2 times x, which is negative 2x, negative 2 times 2, which is negative 4. Now we have one fraction, not very pretty looking, but we'll clean that up. X minus 2x is negative x. Negative 2 minus 4 is negative 6. There's our numerator, and x plus 2 is our denominator, and this is less than or equal to 0. So we're still looking for negative numbers, and now we have our fraction simplified, and we can look for our boundary points. To look for our boundary points with a rational, we take our numerator, negative x minus 6, and we set that equal to 0. Then we take our denominator, x plus 2, and we set that equal to 0. Remember, when the numerator is 0, that says this whole statement is 0, and when the denominator is equal to 0, that says our statement is undefined. So solving now, we can add 6 to both sides, and we have negative x is equal to positive 6. And now either we can think of it as multiplying both sides by negative 1 or dividing both sides by negative 1. We have x and is equal to negative 6. Over here, we can subtract 2 from both sides, and we have x is equal to negative 2. So negative 6 and negative 2 are our boundary points. So let's draw a number line here, and let's put in our boundary points of negative 6 and negative 2. And I like to circle my boundary points so that I don't confuse them with any test values that I choose. We have our number line divided into 3 intervals. Numbers less than 6, between negative 6 and negative 2, and negative 2 and greater. So we're going to need 3 test values. Looking in this interval here, I'm going to go with -7. We can choose anything less than -6, but no need to get crazy with a super small number. -7 will be fine. In this interval, let's go with -5. Again, you could choose any number. And over here, let's go with 0. I always like to choose 0 in an interval when I can because it keeps the math simpler sometimes in dealing with other numbers. So looking at our test values, we have a test value of -7. We have a test value of -5, and we have a test value of 0. We take our test value and we go back to our statement to see what kind of number we get. Is it positive or negative? So taking our -7 and substituting it in here, a -7 gives us +7. +7 minus 6 is 1, which is positive. Don't really care about the number itself. We're more concerned what's the sign. -7 plus 2 is -5. So we have a negative there. Positive divided by a negative is negative. That's the information that we want. Now let's take a look at our -5. Let me put this over here so we can see what's going on. We have -5. -5 is +5. +5 minus 6. That gives us a negative in the numerator. -5 plus 2 is -3, gives us a negative in the denominator. Negative divided by negative is positive. Last but not least, our test value of 0. 0 minus 6, negative in the numerator. 0 plus 2 is 2, or positive in the denominator. Negative divided by a positive is negative. So, looking at our statement, we said our interest was in negative numbers. The intervals that give us our negative numbers are this one and this one, where we had the test value of -7. So all the numbers that are less than our boundary of -6 will give us negative. We also have a negative interval over here with 0, so that says all the numbers greater than -2 are going to give us negative values. Last consideration for our boundary points, are they included or not? This statement here says they are included because it's less than or equal to. Looking at our boundary point of -6, which we got from the numerator, that would be included and it would be the hard bracket. Now, we have to keep our focus here because even though with the inequality symbol here, it does say bracket, because this -2, the boundary point of -2, is from the denominator, we are not going to be able to include it because a -2 in the denominator, -2 plus 2, that gives us a 0 in the denominator. Undefined, huge no-no in math. So the boundary point of this -2 is going to be a parentheses because the -2 can't be included. Finally, we have our solution written in graph form, number line form. Let's put this information in interval notation. We have -infinity to -6, bracket, union, parentheses, -2 to infinity. And that would be the same information written in interval notation.